the late night studios of Way Happy. This is Mr. Meyer, and we are doing the final section, P7, solving inequalities. So what will you learn about? You will learn about solving them. You will learn about solving quadratics and a little bit of projectile motion and, approximating solutions. So what do you need to know? Whenever you have an absolute value of anything, really, if it's less than, I like to think of this as less than is an and problem, and greater than is an or problem. And that's really kind of how I solve inequalities. It could also be equal to, so it wouldn't matter if it's equal to or not. There's still at least and or. And that's the way I always thought of these problems. However, the book, they have a little different technique, which I kind of like too. They just say, if you see a less than symbol, then know that your problem should be between negative a and a. And if you have a greater than symbol, then you have, see, this or problem. So as you think about that, look at this drawing right here. The blue line represents your absolute value problem. The black line represents the solution. So if you want to know when the absolute value is less than the black line, that would be all this part. That's why you go from negative a to a. That's all this area in here is answers. When you want to know when the absolute value is greater than the black line, that's over here and over here. That's why it's negative infinity to here and from a to infinity. So that's why you need to have those two regions of solutions. So here we go. And solving by graphing is a great way. But here's how I solve this. First thing off, I see the problem. I see an absolute value. I know it's a little bit of trouble. Absolute value usually has more than one answer. And so I see the less than symbol. To me, that's an and symbol. So I know that I'm going to have to do less than 5 and greater than negative 5. Or do what the book does. They put the negative 5 and then they go less than x plus 3, which is less than 5. And go ahead and solve that. So as I solve that, I subtract 3 from all sides. And I get negative 8 is less than x, which is less than 2. And there's my solution. All the answers between negative 8 and 2. So I would write that as negative 8 to 2 and solutions in interval notation. And there you have it, right? So that was an and problem. I should probably have done an or problem, but I didn't. Or would be done the same way, except for you can't write it as one big thing. Here you go. We'll add one real quick. X plus 2 is greater than 8. So again, now that this is an or problem, I'd have to do x plus 2 is greater than 8, or x plus 2 is less than negative 8. And I solve that with the word or in between. So x is greater than 10, or, oops, really? 8 minus 2 is 10. And subtract 2, x is less than negative 10. And if you look at that answer, I have my answers now. If you want to put them on a number line to visualize them, that's fine. Here's 6, everybody bigger than 6, and less than negative 10. Here's negative 10, everybody less than that. So negative infinity to negative 10, or the answers would be in the region 6 to infinity. And there is an or problem. So 2 types of answers. Beautificent. Now, what about a quadratic? Now, that's a little harder because it's not a linear problem that I can solve. So quadratic is a little more difficult. Usually I'm going to try to factor, or I'm going to try to use quadratic formula or something like that. And I'm actually going to treat it as an equal sign. I'm going to treat it as x squared plus 3x plus 2 equals 0. I'm going to solve it. Luckily, this one factors to x plus 2, x plus 1 equals 0. And that's really helpful because this is a parabola who has an x-intercept at negative 2 and an x-intercept at negative 1. I know that the graph opens up, so it looks something like this. I don't know exactly how great, but it looks something like that. And now the question can be answered. And by the way, I should have mentioned, you always want to make sure it's related to 0, not some number. And so now I can answer the question, when is my parabola less than 0? Right? Well, it's less than 0 right here in this interval from negative 1 to negative 2. And so I say that. It is less than 0. Now watch out, it's equal to 0 at negative 1 and 2, so let's not include it. And it'll be from negative 2 to negative 1. That is our interval. You could have graphed it on a graphing calculator, or you could have graphed it on Desmos, or if you know what the graph looks like, you're good to go. And last but not least, projectiles, right? We have an equation for projectiles, and you just plug in the missing parts. Here is the projectile equation, and you just need to know the different pieces. S is the height of the object. T is time. V0 is your initial velocity, so usually giving you at a speed of how fast a projectile is flying. And S sub 0, S is our height, so S sub 0 would mean our initial height, just in case you need it. So I don't know, let's just say that I throw a baseball from 5 feet off the ground at a speed of 20 feet per second. Okay, so if you had that information, your initial velocity would be 20 feet per second, and your initial height was 5 feet off the ground. And then I could ask you questions like, what's the height after 2 seconds? And so you'd say, well, the height after 2 seconds would be negative 16 times 2 squared plus the initial velocity, 20 times 2, plus the initial height, 5. And that would tell you the height of the ball after 2 seconds. And that's all you do. Type that in, see what you get, right? Whatever 4 times 16 is, what is that, 40, and 24 is negative 64. Oh, this is going to be interesting. We have a negative 64 plus a 40 plus a 5. So the ball is already underground. Nice problem that I just made up. But that's how you would do it. After 2 seconds, we would say the ball is 19 feet in the ground. Good? All right, have a great day. Stay happy, and I will see you soon.